Hi, my name is John Johnson. This is my talk on loading single-page apps, which have been mentioned a couple of times. I work on PHP and Symfony and JavaScript in a project that's called Ilios. You want that back? My slides are on there if you want it. And if you, that's a good point. If you'd rather read this as opposed to listen to it or see my interesting speaker notes about myself, the site is live. You can totally check it out. So, okay, I work on a project called Ilios at the University of California, San Francisco. You don't really need to know about it unless one of you happens to be the dean of a school of medicine, which I don't think is true of this group. I'd probably know you if you were. What's important about Ilios is it's a 20-year-old project. We started with an Access database. We moved to ASP.NET. I wasn't involved in any of this. It became a PHP app, became a PHP app again. In 2014, we rewrote the whole thing in Symfony, and we're very happy with that choice. But that's kind of going to inform the subject of the talk a little bit. It's built by UCSF, and it's available for free to all of the universities. It's an open source project. It's basically used around the world by lots of things, generally medical, dental, pharmacy, nursing, veterinary schools who want to organize their curriculum. One of the interesting things about our problem is we actually distribute the PHP as downloadable content, and it's run on university systems. Those systems may be under somebody's desk, or they may be a giant IT architecture at a university. So we kind of have to balance what we're providing and what we're delivering to meet the needs of both a single user running a single site versus the configuration required by a basically large, huge IT organization of a university, which might have tens of thousands of servers running at the same time. That's kind of important because when campus IT supports our system, they're not going to update it that often. They're on the kind of IT lifecycle you'd see in a Fortune 500 company where they're busy doing other things, and every quarter or so they can get around to updating the software. So I hope some of this is sounding like familiar territory, even though we're running a university. Some of it probably won't, but hopefully our solutions will look familiar. We selected Symfony. We had an incredible PHP in-house experience. We were very happy with Symfony. We also picked a framework called Ember.js to run our single-page apps. Hopefully you're all familiar with Symfony, given the conference that you're at. And I'm not going to talk a lot about Ember, but we love it. So if you'd like to go on about it later, you can totally catch me after this, and I'll be happy to go on about it there. The real key for us, though, is that we've broken this up into a REST API and a single-page application. The REST API provides the data. We ship that PHP application out. We provide it as a downloadable thing. You can get it. And then we have this single-page application which can be updated dynamically, usually on a cron job inside the PHP app. So we're able to constantly ship updates to our front end without needing to have campus IT organizations update the entire stack. So that's been very successful for us. We're also really happy with this because we can build and test the two systems completely independently. There's an integration where they come together, obviously, that we need to worry about if the API changes. But generally, we're able to test the front end, test the API, ship both completely separately and independently. So what's a single-page application? Well, this is the official definition, which is terrible. I'm just going to focus on these parts. All the necessary code, the HTML, the JavaScript, and CSS, is retrieved with a single-page load. So basically, your entire application is retrieved immediately. The page never reloads. You can fetch new data whenever you need it, the dream of Ajax. And it really involves a lot of dynamic communication with the web server. The one big key here is it doesn't reload ever. So we have to manage state on the client, on the browser, and we have to manage the communication back and forth. But we're really going to provide so much of the architecture of the application at the beginning, the HTML and CSS, that every page click will just be loading a new piece of that. But that comes with some downsides. So let's talk about structure. This is a Symfony loves PHP conference. PHP loves HTML and CSS by the transitive property of loving things. I hope you all love HTML and CSS. Okay, so this is what an application looks like when it's structured as a single page app. Let's see if we can go up here. The key parts we're going to look at here are that where assets are loading, our vendor, our JavaScript is loading, CSS, HTML, everything is loading inside the same HTML app, but there's really no content here. There's a body tag. Occasionally there'll be a div to load into, but a lot of times there isn't even that anymore. Nothing the user is going to interact with is involved here. If you're looking at this in React, another popular framework, you're going to see it's basically the same thing. With Vue.js, you're going to see it's basically the same thing. There's a little bit of variation between these things. Angular, essentially the exact same thing. And if you're using Webpack Encore, this is what the documentation tells you to do. You have a lot more flexibility with Webpack Encore. If you're using it for a single page app, it's basically going to be the same thing. So, because there's no content on that first page, there's a default user experience. You're going to load all that stuff, but you're going to pay for it right at the beginning of interaction with the application. To users, that looks like this. If you load an application on a slow network and it has even a few hundred kilobytes of JavaScript assets and CSS, they're going to see this white screen for a long time, a very long time. I'm going to leave it up here because it's an agonizingly long time, okay? And that time is terrible. We have faculty that work with our Ilios application, just our UCSF instance, that are flying all around the world. They're working on airplane Wi-Fi, they're working on shoddy internet connections, they're working on great internet connections, but even at the speed of light, going around the world takes time. And that time really starts to add up. And we really don't want anyone to feel like they're wasting their time. Because at the end of the day, what we're trying to do is educate and graduate medical students, pharmacy students, dentists. We're trying to get them these white coats. We're trying to get them out the door. And we feel like when we're wasting even a little bit of their time, that we're standing between them and saving lives. So what can we do about this process? First of all, before you get into anything I'm going to talk about, you should fix everything else in your app, okay? So some things we've found remarkable performance increases with. Getting up to date. Symfony 4 is significantly faster than Symfony 3. We're not really sure why yet. We haven't looked at why our app is a little bit faster, but we've noticed our click rate is much, much faster. We saw a substantial improvement when we started to serialize in our API DTOs, which are just a plain object. Several people have talked about the cost of serializing complex objects. Doctrine entities are complex objects, and serializing them is a complex process. So those are two things you can just look up. The other thing, Blackfire. If you haven't played with it yet, it's so cool. You throw your app in there, you can put it in a Docker container, you can run a couple clicks on your app, you can look at a report, and you will see giant blocks of optimization that you can make. For us, we save something like a second on every transaction just by caching our annotations, which kind of could have been on by default, but we had a little bit custom annotations cut up to our DTOs. We hadn't used the right class to extend from. I swear to you, one line of code changed, saved us a second on everything. Blackfire found that for us. Definitely use it if you haven't yet. And when you've got all that done, when your app is fast in other ways, then you can start thinking about these tiny micro optimizations that basically I'm going to spend the rest of the time until lunch talking about. So hopefully I haven't discounted it too much. The first thing I like to think about is loading a single page application comes in two parts. There's the first time that somebody arrives on your site. They're new, they have no cache in the browser, they've just followed a link or a bookmark or something in an email and they've showed up on your site. But they're getting a first impression. That first visitor is getting a first impression. And for us, sometimes that's the person making the decision. They're going to spend 15 minutes on our site and decide if they want to use Ilios for every educational decision for the next 10 years. We might only get 15 minutes. If we spend 3 seconds of that loading a white page, and maybe they get concerned they didn't follow the link right, so they hit refresh, or maybe they hit back and then refresh, there's a loop here where you could never see the app. You could just see that white screen over and over and over again, just time and time again. So other thing about first-time visitors is they're really paying attention. They click something and they watched it load. And that means that agonizing slowness of the load can really affect your first-time users. They also have no idea if they want to use your system or not yet. They haven't decided to pay the bills. They haven't decided to subscribe. All they're doing is making a decision. You don't want that first decision to be, this takes forever to load, I don't want to use it. You'll hide basically your entire app behind that. The second visit, the super happy visit, we can play a whole bunch of games with the second visit. The thing to remember about these is these are folks that are already using your application. They're your biggest fans. They're the ones that are coming back over and over again. We want to make sure we're treating them very well. Any cost we charge them in loading time, they're going to pay over and over and over again. They're going to pay every day. For our application, which is essentially a productivity app, we have users that are on it for 6-8 hours. They might come in and out, in and out, in and out. They might use it 5 or 6 days a week. If we have a 2-second loading time, that adds up to actual value and actual time. And they're willing to wait because they know how good you are. I know you're all building excellent applications. I know we are. We know how good we are. Our users know how good we are. They're willing to wait for it. They shouldn't have to wait though. So the second visit, as I said, is super fun. We get to play with cache. There's all kinds of tricks we can play. We can use service workers. We can use some really magic to speed up the trip. But that's not where the money is. The money's in the first visit. The money's in getting the customer. For us, it's in getting something to like our app and use it. We're giving it away for free, but we still want people to use it. So all the real content should be on that first visit. And there's a couple things you can do on that first visit to absolutely start to pay those bills. The first thing is sending less content. One of the ways you can do this is by server-side rendering your JavaScript application. This is going to replace that HTML page I showed before with HTML, CSS, and DOM that the browser can parse. This is a fun trick to play, but it has all kinds of downside that has to do with the JavaScript loads in the background and maybe links won't be active. You really have to play around with it to get it right. It's difficult to test. This is great, and if you have the time to spend on it, it's an excellent way to do it. But it's not really what I'm going to focus on. One of the things you can definitely work on is counting the bytes. So I started building websites in 1995 when we counted tens and hundreds of kilobytes. And the chemistry professor that taught me to build HTML said 100 kilobytes was too much for any website. No one needed more than 100K. That's almost as ridiculous as the no one needs more than 512K of RAM, but that's where it is. This is an area where we start to think about it again, though. 10K is too much for an index.html page. It's too much for that first load because you really want it to be instant. It's really worth trying to think about those budgets again. What is the smallest amount of data you can send to the user? 10K is a pretty good chunk. Clicker died. Fantastic. What can you load later? We found tremendous performance improvements in finding the libraries that we weren't using occasionally and loading them asynchronously. For us, this was two things, big things. Pop-up parse is an excellent CSV file library in JavaScript. It's fantastic. We need it on maybe 3 pages on our application. Load that later. That's 400K, shot right off. Dropbox has a password strength tool. It's called like ZXCVBZMK something, I don't know, something like that. Again, 400K. We only need it when users have to type their passwords. Load that asynchronously. Try and find these things where you can send a little bit less and send it later. Code splitting is a fantastic technique. It's just starting to really hit its stride. This is the idea that you let your framework choose what to display on a page. It knows the routes, just like in Symfony, your JavaScript framework knows the URL somebody landed on and maybe what resources are needed for that URL. Code splitting can help you send just what you need to load that page interactively. Definitely check that out. It's new. There are issues. There's places where you'll end up with a completely non-usable app because JavaScript files don't load in the background correctly. But it's something to test and play around with for sure. Interestingly, the compression algorithm you choose starts to matter here, which is crazy. But if you're sending a few tens or hundreds of kilobytes and you can shave off a few percentage points, you can shave off that time. So you're definitely going to want to gzip all your assets. But if you're working with modern browsers, you should investigate something called Brotli, which is just a tiny bit better for the web. It's just a little bit better, and it's definitely worth looking at. It does mean your app probably won't load in old browsers, and we're going to talk about handling those errors in just a second. Again, we're trying to shave off milliseconds. We're really focused on that instant of brain activity when someone goes, is this working? And then, oh, I guess it's working. But we want to avoid that panic. And when you're trying to shave off those milliseconds, every tiny fractional piece of time really does start to matter. So the next thing we can do, now it worked, is send things fast. HTTP2 push, fantastic. This is all the code you need to turn your Symfony asset requests into HTTP2 push requests. You're going to need to enable a module in Apache to make it work. It, I think, works out of the box in Nginx. Fantastic. Web link component doing really good work for us here. What HTTP2, I'm going to stop saying that because I can't, does is stacks up all the assets needed for a page and sends them all at the same time. So along with the request for index.html, it will send a bunch of headers that say, oh, by the way, you're also going to need this JavaScript file, this CSS file, and these images. I'm just going to send them to you at the same time. Again, when we're trying to shave off milliseconds, the idea that you don't have to open a new network connection to grab each asset, even if they're small, really starts to add up. That process of opening a connection actually costs you time. The most fun thing to do is to distract our users. That's where we're going to find these loading symbols, loading animations. There's a few things you definitely want to be aware of here. The pithy saying, the fun thing, is funny like the first time. The 7th or 8th or 15th time you see it, probably the first time you opened Slack, whatever they said to you was hilarious. But when you see that message again, you're like, that's not funny anymore. That thing about the bear, I don't care. Whatever it is, over and over again, repetitive. I had an app one time that instead of having a spinner, it said spin, ... spin. I laughed so hard the first time I saw it. I laughed so hard. The next time I was like, yeah! I mean, just 2 times. So beware of those things. They are funny. But remember, your users are going to be loading this stuff all the time. The other thing about animations is they freeze. The browser does all kinds of complicated tasks to render things on the screen. And without really focusing on 60 frames per second game-style animation, you're going to get lockups. One of the interesting things about that is you got to watch out for lockup metaphors. Because we're mainly a medical app, we used to have this as our loading animation, this fantastic heartbeat. Unfortunately, sometimes it gets jittery. And our users actually said to us, I don't understand why every time I start it, why Ilios has a heart attack. It's not a great first impression. That's not really what you're going for, is a bunch of doctors wondering what's wrong. The last thing about loading animations is the order really matters. Sometimes you'll spend a lot of time on your animation and you'll still see that white screen. And I'm definitely going to dig into why that is. So let's start with what a real nice, basic, simple HTML page might look like. We're loading a couple of scripts and we're loading a CSS tag. If we throw an animation in there, hopefully those comments are clear. I put a pithy saying in here like I told you not to, but that's my loading thing. That's what I'm going to load. Well, in order to understand what's happening, you sort of need to understand this chart about how the browser built the DOM. I'm not going to make you do that though. We're just going to put some wait things in here. Every time the browser hits something they have to load from the network, it waits. So when it hits a CSS file, it doesn't keep going. It just holds on there and waits for the CSS file to load. And then it hits the next element and it waits for that to build. DOM elements like H1s, divs don't cost you that much. It's instantaneous. But network requests really do cost you. So if you've structured your app in this traditionally recommended way, where you put CSS on top and scripts on the bottom, your users are still going to have to wait for the CSS to load before they see your loading screen. We can do some stuff with that. One, we can throw the styles inline in our index page just for our loading animation, which lets us kind of group everything together and then worry about the rest of the application loading after that. And then I've put my link rel style sheet down here in the body. This is legal for very few link elements. It is definitely legal in all browsers for rel equals style sheet. So that's fantastic. You can actually start the network request for your style sheet after your loading animation or whatever it is has shown up. This means that when the user loads this page, the browser is going to go, oh, a couple of tags, HTML, head, body, style. I can read the style. I know what that's going to look like. H1, throw it on the screen. No network request except for the first one. That's pretty quick. You're going to get a lot of gain out of just doing this, just from saving yourself from loading that original style sheet. And the CSS needs to block our app. That's how we avoid getting that flash of unstyled content that we've probably occasionally seen on the web and used to be a real problem before we started to figure this stuff out. But with a single page app, the CSS really needs to block the booting of the application. It does need to block our loading screen. So we can put that CSS down there just in front of the app. Taking advantage now of how the browser loads things, it's going to go load, build, show the screen. Oh, CSS, wait, get it. Oh, JavaScript, wait, get it. Oh, JavaScript, wait, get it. The last JavaScript boots the app. Everything goes away. Fantastic. We've avoided our users having to wait for that process to happen. There's some other nice things you can do in modern browsers. This defer attribute you can put on JavaScript assets. Says you can load them simultaneously. A lot of this stuff isn't going to necessarily pay dividends, including the CSS place if you're using HTTP to push. I did it one more time. Because that's going to kind of let everything load at the same time. But when you're talking about opening and blocking network requests, these defer attributes help a lot. It tells the browser, okay, I'm going to load some JavaScript. Don't parse it yet, but keep going down the page and get the next one, and the next one, and the next one. And I don't know if you remember, but the Angular HTML, Angular loads 8 or 10 different JavaScript files right up front. Adding this defer attribute lets it say, go get them all, and then parse them in order when you finally get them all. And the parsing does take time, but nowhere near as much time as the network request does. Okay, there's a little bit of information there on defer if you want it. So, another piece of loading, don't forget that NoScript tag. When your app is entirely in JavaScript, you're really going to want to present the users with something if the JavaScript is turned out. One of the really fun things we discovered is you can completely style a NoScript tag. You can make it look fantastic. You can throw a NoScript tag on your site, you can reach into that element with CSS, and you can style it to look great, which means your users are going to get a great experience when they don't have JavaScript turned on. In our case, we don't bother with instructions. There's a fantastic library called NoScript something. I'll probably should have thrown a link in here. That just has instructions in a lot of languages for how to turn JavaScript on in your browser. That's fantastic. Just provide it to users. We're finding less and less that that's actually a thing. People are browsing without JavaScript. It's just fairly critical to the web, but it is important to account for that. The other thing that's particularly important in loading for us to account for is parsing errors. We only support the latest version of evergreen browsers in Ilios, and we require everyone to keep up to that standard. That means, however, if you visit our site in IE 11, which is still moderately popular, you're going to get a broken page. It's not going to do anything. What happens with loading indicator is it just loads forever because the JavaScript never loads behind it and takes that indicator off the page, which means somebody visiting our site with an old browser could conceivably sit there for as long as they have patience and wait for something to happen. It won't ever happen. It'll just sit there and load. Handling parse errors is fairly easy. You can catch that error with just a little bit of JavaScript. You could, again, inline this into your HTML if you want, but you don't have to. You can load it as a separate script just right up there on top. Make sure it comes in before your app, and it will catch all the exceptions in parsing that your app throws. What we do is we just put something up on the screen at that point that says, we only support these browsers, and we provide a list. It's a nice way to go. It gives people some indication of what happened. Every framework I've played with is going to catch errors once it's booted. It's going to have its own error process. This is really the only time you need to catch errors in a classic JavaScript way where you're listening for events. Okay, let's talk about things you can do on the first load to make that second load better. The first thing you want to do is fill that cache. I think this might be my only slide with Symfony code on it, so enjoy it. It's here. This is the Symfony part. Symfony makes it incredibly easy to fill your cache. And with single page applications, we're really talking about two things. Things we're going to cache forever, in this case a year. That's your fingerprinted assets. If you have a JavaScript file and you use some kind of hashing system to add a fingerprint to the end that says when this file changes, so will the name of the file, you can cache those things forever. There's really no need for browsers to ever fetch them again because if you need a different file, it'll be called something else. The other half are things you need to validate every single time. The interesting thing is you don't need to send them every single time. And Symfony, through the request and response system, provides us a really nice way to use e-tag headers. Right now, this is just hashing some content and setting an e-tag header. What that does is it tells the browser, whenever you want this file, you have to ask if it's new. If it's not new, I'm going to send you an empty response with no content in it, again, as fast as possible. But you still have to ask every time. You never just get to use it. This is the kind of thing you're going to use with your index.html page. You don't want to send that 10K of content every time, but you do want them to check in and see if the application has been updated since the last time they visited. No cache is on there. That doesn't mean don't cache. It means you have to revalidate. There's some fun little quirks with the caching system on the web. And this can all be done in Apache or your web server. I like to do it in Symfony partially because I'm much more confident in PHP than I am in Apache config. I have that giant book and I've never read it. It's horrible. The other part is we're distributing our app, and we don't want to have to include that kind of instruction in our application. To go into your Apache config and set up your virtual host to make sure fingerprinted assets are getting sent correctly, that's a big pain. This way it just works. Symfony can do it for us. It's probably fractionally slower because Symfony has to boot and run in order to serve this asset, but we're not quite at the level we need to think about optimizing that. At scale, you might want to consider that if you have tens of thousands of simultaneous users, something like that. The actual asset loading could affect the memory footprint of your machines, but it's not a problem for us. So we can also fill that cache with our index.html page. And we can do that using service workers. Service workers are the hotness in JavaScript right now. It lets you background tasks. It lets you put things in a cache that's different from the browser cache. It lets you play a lot of fun games. So what that might look like is something, this is super basic. The good parts, we use a little bit of JavaScript code. We say when you're looking for the index.html page, right here, instead of just serving it up, look in the cache first, and then serve up the cached edition if you have it. This is very interesting because it means on the second visit, the user doesn't even have to look and see if the app has been updated. It doesn't have to fetch anything. It can just serve a cache version, and then you can play games and do processes to look in the background and see if anything's changed. You can present the user with a nice UI. In our case, it says, huzzah, Ilios has been updated. Click here to get a new version. You can play that game however you want. But users that are visiting your site for the second time with service workers enabled are going to get a loading indicator immediately. They're not going to have to fetch or load anything. It's going to happen super fast. This is as close as we can get to the native app experience of instantly seeing something when you click a button on the screen. The bonus of service workers is they work offline. So the web is getting interesting now. We can start doing things offline that we've never been able to do before. We can cache the data that powers our app. In a lot of cases for us, many of our users want to just click on something and see their schedule for the day. We can start to cache that so it works no matter what their network infrastructure looks like at the time. Whether they're on an airplane or they're driving in a car, or they're in an elevator, which is pretty common for medical centers. The elevator thing, it's pretty bad. If you've seen Grey's Anatomy, it's just as bad as that. Okay, they can still load their schedule, and they can do that by caching both the index to HTML and the data. We haven't actually gotten too far into caching the data because there's all kinds of UI stuff to it that we aren't quite comfortable with the idea that maybe your data's stale or it's not stale. But that might not be true for your app, and you might be ready to jump on that. There are some bad parts of service workers. I would feel bad if I didn't tell you about them. If you set your cache headers wrong, and you tell service worker to cache itself when you send it from Symfony, that cache will live 24 hours, no matter what else you do. You can tell this is an obvious foot gun because the spec says it can be cached for no longer than 24 hours. So I imagine the first couple people that played with service workers sent the wrong cache headers and realized that they bricked their user's browser forever because it would constantly serve cached content forever and never look again for anything new. So that's a problem. You can shift refresh. It's hard to tell users to shift refresh to get your app to work. So I recommend definitely paying attention to this right off the bat. Even after you replace a worker, workers replace themselves. So they replace themselves, another one waits in the wings, and then starts to serve the next request. That means the very next time your user visits your app after you've updated it, they're going to see yesterday's version or last week's version. This can kind of be a problem if you have bugs. For instance, we accidentally hid that huzzah banner of ours behind another banner, so you couldn't click it and get the updated app, which meant for 24 hours there was no way for a user to get the new application that we'd served them because it was hidden behind. It wasn't a huge deal, but it is something to pay attention to. You just want to make sure that you understand the life cycle of service workers, that they're always going to sort of live on and be sitting there waiting to bite you. The syntax of service workers is a little messy. It's kind of classic JavaScript. It's a little over-engineered, but it's over-engineered for a reason. It has incredible power. If you can, you should use a library to abstract this for you. Excuse me, the Ember.js library abstracts it for us. We're very happy with the Ember service worker implementation where we have to do almost none of this backgrounding task stuff because it is a little messy. But you can do it by hand if you need to. If you Google service workers, the first 25 results will be about creating a service worker kill switch. This is the best one I know of. If you send this service worker, it will immediately shut down all other workers and grab the content and take over the page. It's not super good user experience because it does weird stuff, but if you absolutely have to kill one of your service workers, you can send this. But if you've sent bad headers, you're still going to have to wait 24 hours. So this isn't going to get you out of that boat. So always be very careful when you're sending those service workers. They should never be cached. They should always be sent with that e-tag must revalidate kind of concept that I've talked about before. So, are they worth the risk? Yeah, they really are. Aside from this tiny little bit of caching index.html, getting into service workers is going to give you things like push notifications, background rendering, lots of data caching, lots of things you can do, lots of games you can play to make your app a little bit better and a little bit faster. And that first step into going offline, and going offline in your app can really improve the user experience when you're talking about something that's fairly data heavy. So I've got a little bit of bonus content here, which I have time for, even though I think I'm going into lunch. We'll see how that goes. Progressive web apps, very exciting. Lets us take a JavaScript application and install it on a mobile phone, or really any device. You can install it on your Mac if you want. That's the official definition. I think it's best seen in 2 slides. This is Ilios. At the bottom of the screen, you're going to see add to my home screen. This UI is different in different phones and devices. It can be install this app or install this device. When you install it, you're going to get our JavaScript application running up here with all the other apps. It looks just like everything else. It looks just like the Starbucks app. It looks just like the Amazon app. It looks the same. And when you click it and open it, it looks the same too. It never opens in a browser window. What it does is open in a chromed out version of the browser that belongs to you. We've oranged our status bar here to take over a little bit more. That really gives you that kind of power to be serving almost an app-like state from a JavaScript app, which means you don't necessarily need to maintain 2 sets of UI. So what do you need to do a PWA? The first thing right off the bat, you have to have a service worker. It has to work offline in some way. The phone can't be guaranteed to be online, and the standard requires that you be serving something offline. You can just serve your index page offline. You could even have a service worker that does nothing, but that would sort of be cheating. There has to be a service worker. They also require HTTPS. As I hope you got from the last talk, if you're not HTTPSing already, you really should be, so I'm going to skip over that one. You have to write a web app manifest. You can actually do this freehand, though there are certainly tools to do it. It's like 15 lines of XML that say what your icons look like on a phone of various sizes. And you need to support deep links. So deep links are a JavaScript concept. They're really a web concept that if I go somewhere and I bookmark that URL and I go back to it, I should land where I was. I shouldn't land on the home page. I shouldn't land on some other random page. I should land where the URL is. That means the URL controls the state of your application. If you're working with a modern JavaScript framework, anything after Backbone, say 7 years old, you're going to have deep links probably enabled anyway, but it is something to pay attention to. When your users add to home screen, they're going to be adding a section of your application to the home screen. An actual URL is what is stored. In our case, that might lead to an individual course or an individual calendar entry or something like that. When they follow that link, they should land back where they thought they were going to land. There's an option to override this in your web app manifest, so you can say, if the user regular expressions any of these things, they meant the dashboard, so just send them there. So we have some options to get around that, but you do have to support the deep link. I don't know, is this the end of native apps? I really hope so, because I already know the languages I know, and I don't want to learn any more languages. It might be, it might not be. APIs certainly help, and progressive web apps can certainly help even more. So, thank you very much for this conference, for giving me the opportunity to talk, and for the UCSF library who pays me to do open source work, talk at conferences like that. So my Ilios team is here, thank you to them. And now, before we go to lunch, if you ask me 3 questions, I'll let you go. It can happen. But you have to ask at least 3 questions. Yes?
Do you use JWT?
Yes. So,
How do you handle the issue of trying to validate somebody after they have it? I mean, is it just store it and remove it?
the question is, do we use JWT, and how do we validate the users after they have a token?
Yeah. So say that they got a token for 24 hours and then that user's has been removed for security purposes.
Yeah. So what we do with our JWT is it's stored in the browser in a cookie and gets sent with every request. If it was expired, that's where Symfony comes in, and it looks to see if the users expire and then starts returning them expired headers instead of non-expired headers. We don't store in our JWT session information. What we just store is the username, and we really validate that on every single request. So we don't get in the case where the token lives on longer than the user can, because we're validating it every time. We also have an expiration system, because what we're really concerned about isn't necessarily that case. It's the case of somebody has lost control of their token. You know, I accidentally sent an email and it's out there or whatever. I put it on a website. In that case, we do, our token does carry an attribute that when it was sent, and we have something in the database for users that is when the last token is useful after. So you can invalidate all your tokens that happened before some date. You basically hit a button in the UI and you say, any other token I've ever gotten is invalid after today. And that's really the only way we can come up with to handle that. That's 1, 2, yes.
Any thoughts about loading multiple images on the first load? Like,
Images are tricky because they're so huge, right? I had that Ilios thing on the front. That's an SVG. SVG has been great for this for us. It's compressible. We send it with the index.html page, and it's very small. You could certainly load multiple images, but every image you hit is going to trigger that network request and is going to cause that instant of slowdown while they load the asset. I wouldn't use an image over an SVG unless you absolutely have to. And then really think about the fact that by the time that image loads, the user will have had to wait for it to be fetched. Another? I'll let you off with 2 if you have to. Yes?
there's a Symfony project called API Framework.
Yes.
Have you used it? What do you think of it?
We got on our API in 2015, and API Framework was announced at SymfonyCon in 2015, I think, so we were already too deep in the woods to make the transition. We're currently API version 1. Sorry, the question was, have we used API Framework? Our API is versioned at 1. It's a JSON API, which is now supported in API Framework very recently. When we go to version 2 and move up in the JSON API spec, we'll probably try and work API Framework into our process. We haven't really needed it at this point. We don't have you know, we've got 75 or something endpoints, but most of them work off the same API controller. It looks at the name of the endpoint and loads the right entities and works with the service to do that. So we're not sitting on a bunch of code that we're having to maintain. And we're already up and running with all the things we wanted, so we haven't made the move to API Framework though. I've been following it and I love it and it's great. If you're ready for it, if you're building a new API, I'd definitely start there for sure. Especially because Flex loads it up real nice. Okay, that was 3 questions. I can totally take more, or we can go eat. Fantastic. Thank you very much. Come track me down.